Okay, all of this is just software process stuff. Okay, this in some sense is really good common sense. People should do this. We don't see enough of it being done. I think it'll help if people do more of it. Our focus is in providing help for all of these things by building tools to help along the various aspects, and we'll see that. All right. So if you can build automated tools, you can enhance productivity, okay, by backing these things up, by providing better insights to the code, by being able to carry out the tasks reliably. Let the tool do the work, let the engineer say what to do. Okay? And finally, by performing tasks that engineers cannot do by themselves in any reasonable length of time. Okay, so what do we do as a company? We have an engine at the core called DMS, and I'll explain what this engine does in a bit. Okay? This engine accepts a number of interesting kinds of things. One, it's language agnostic. Okay, we explain to it what the computer languages are, okay, that make up the customer systems. We give it explicit descriptions out of the back of the Java manual or the IMS manual. We actually describe that to the tool, and then it knows how to process that language. We also give it task definitions. This is what I want you to do to that language. Analyze it for this, look for that, so on and so forth. Right? Based upon the tool definition, the task definition, we establish services to carry out some activity for a customer. You want to do a migration, you want to do testing, okay, you do configuration management. We describe what that task is and carry it out. Okay, and based upon that and help with IT service providers like Renewal, okay, we provide solutions to the customers. So this is kind of us as a company. Right? I'm going to talk about the engine a bit. This engine is based upon a sort of very simple view of the world. Okay? In order to get any automation in tools, the tool has to understand what's happening in the code. If it doesn't understand it, it can't do anything really interesting. Okay, the best technology that we have for understanding what's going on in the world essentially is compiler technology. Okay, there's an automated tool that every programmer has on his desk, which is unbelievably valuable, called the compiler. We all forget it exists. Okay, what makes it valuable is it knows a lot about what's going on in the code. Basically what a compiler does, it reads in the source code, it builds a bunch of internal data structures that represents the structure of the program and how all the pieces fit together. Okay, it carries out specialized analyses for optimization purposes. Okay, it transforms that code into some low-level machine code of some kind and spits it out to an object code loader. That's what a compiler does. Okay, our insight is that idea can be used to carry off all kinds of software engineering activities by making those variables. Let me give you an example of what that looks like. So to start with, most compilers only work in a single language. Lots of people have COBOL compilers, but you can't explain to that COBOL compiler to process Pascal or DB2, okay, or a job control language. They can't do that. Okay, well, so that's the first thing that has to change. You have to be able to wiggle that input. So we give language definitions to our engines as explicit artifacts. And we've got like 25 of these things, including the different dialects. There's like 13 dialects of COBOL. Yay. Okay, and every year IBM invents another one. Okay, so we give it a language definition so the tool can manipulate that language, whatever the particular customer has. And we have a library of these off the shelf, okay, and we enhance them over time. The other thing we do is we tell the tool, what do we want to do to that language? Read the language in. Analyze it for what? Analyze it for structure, analyze it for data flow, analyze it for bugs. Look for interesting problems. Okay? Given that it does that, okay, then the engine can then read source code files for a large system. Most compilers read one file. Okay, our tool reads thousands of files. It wants to read the whole system in at once because you have to reason about everything. Reads the source files, builds up those compiler-like data structures, carries out the analysis, okay, and then depending on what we actually said to it, okay, if we said, I want you to report on problems in the source code, it will give us analysis results. Complain about these kinds of problems in this kind of way in the document. Right? Usually, analysis is just a lead-in. If you go to the doctor and you say to him, doctor, what's wrong with me? And he says, you have cancer. Okay. Do you leave the office? No, the next question, what are you going to do about it? Okay, so the question is not analysis. Analysis is a nice step. It's useful. The question is, what do you do with it? So what you really want is analysis results to drive the transformation process. Use those analysis results to drive a change. Cause something to occur inside the system to improve the circumstances. Okay, so what we tend to do is we tend to take these analysis results and drive an improvement process, an automated improvement process to the source code, and we output revised source code files that correspond to those things, maybe in the same language, maybe in a different language. So that's the core engine. We wiggle those two things, we get lots of different outputs. Okay, that engine, the things inside the box don't change. Here's what we wiggle. We wiggle these depending on what the customer wants to do. Okay, so the way to think about DMS, okay, it's a tool. But a better way to think about it, it's a tool generating tool. By giving it a description of the tool we wish it was, it then becomes that tool. So you can imagine it being a robot whose job it is to manufacture specific tools, okay, that are specialized to your particular task. Okay, so it's good at your system, okay, not at something very general. Okay, so what we're going to do now is go through a bunch of examples. I am not suggesting that these are examples that you should take up and run away with and go use in your system. These are examples that we have found useful for some of our customers. Each one has a different view, which ones are interesting, okay, in their particular system. And so this is just intended to be an idea generator. Okay, what would be good for you? Is this one close? Okay, but our real business is customizing, building custom tools that are specific to the problem you have. Okay, so here's a very simple one. Okay, most application engineers are faced with this giant system, and they don't know how to find anything. Okay, just find something. Right? What you'd like to have are tools that will allow you to search across the whole system, okay, in whatever languages it has, not one language, okay, and hunt for things. So just think of a source code search engine. Think of Google for code. Right? So what you want to have is a beast where you can actually say, I want to go find, you can't read it very well, I want to go find a variable related to tax. Okay, it's somewhere in the system. Okay, and I want the tool to fish through all the code and find all the tax variables. Well, that's exactly what this tool has done. It's found all the hits in the system. This is a natural system with about 2 million lines of code in it. Okay, I think it was up 9,000 modules. A lot. Something you don't want to search with an editor one at a time. You just don't want to do this. So 9,000 modules. It gives you a list of all the hits. And you can pick a particular hit, say, click on that hit. I want to see the line of code that's there. So this is a way to poke around the code. We call this good information, not great information. Good information, fast. It gives people a way to look around the system, helps them understand what change impact might be, okay, where they might have to go, what they might have to do. Okay, so that's just help me see better. Just help me see my system better. The tool is language agnostic. We can give it several languages. It will search for a tax variable across several languages at the same time. If you've got PL1 and COBOL and you find a tax variable, it will find them all. You can see both of them. Okay, that's looking in the big. Okay, you might consider looking in the small. Okay, somebody focused on a particular module, okay, several thousand lines of COBOL. Okay, well, where is this variable defined, and where is it used, and how do I locate that? So this is a language-sensitive source code browser. So it understands the language. It understands which things are identifiers. It has a complete cross-reference, okay, of all the identifiers that are in there, and it knows how to navigate from the cross-reference down to a definition and all the uses, and from a use to a particular place in the code, from a particular place in the code, back to the definition point so you can follow it there. So click, click, click. And the programmer can find his way around that program, 2,500 lines. Right? All right. So we looked at looking in the system in the big. We looked at looking in the system in the small. When you think about breaking out a system into pieces, okay, if you want to modernize a component of it, you don't want to modernize the whole thing in one chunk. If you want to break out the components of it, you want to pick out a subsystem. Okay? When you got 10,000 modules, how do you find a subsystem? What is a subsystem? And the answer is a set of components that are tightly connected. How do you see tight connections? How do you see a place you can take that lump and pull it off to the side and say that's a subsystem that's worth replacing? So the first thing you have to have is something that will go through and look at all the files and look at how they're related to each other. So here I have a COBOL program that's reading a database, and the database goes over to some other program which is processing it through a shell script and feeding it off to something else. So what you understand is the connection between the artifacts of your system. Okay, the code modules of various kinds, whether they're database components, whether they happen to be code components, screen definitions, whatever they are, and the things that they connect to. And that gives you kind of this giant graph. Now imagine this graph is a big graph. It's got 10,000 items in it. Okay, so that's one thing you want to do. And you want to have the tool come along and say, I think these things are clustered. You want it to group things and say, these are tight groups. So this group of things is tightly clustered, and this group of things are tightly clustered, and this group of things are tightly clustered. And those edges that cross the cluster boundaries, these are natural fractionation points for your system. So if you want to think about replacing a subsystem, you need a way to find that subsystem. You need a way to break it out and say, I can take a pair of scissors and snip here and pull this thing off to the right. And now all I have to really do is to figure out how to replace that link and that link. Okay, it actually makes this a lot more practical. So this is seeing the system as structures.